What is buckling in bridge failures? Imagine walking across a bridge and suddenly feeling it wobble or bend unexpectedly. That unsettling movement could be caused by a phenomenon called buckling, which plays a big role in bridge failures. Buckling happens when a structural part of the bridge, like a column or a girder, suddenly deforms under pressure. It's not because the material breaks, but because it loses its stability and starts to bend or twist out of shape. This usually occurs when the compressive stress on the part exceeds what it can handle. In bridges, slender components like columns, beams, or cords are most vulnerable to buckling. When these parts buckle, their ability to carry weight drops sharply. This can cause a chain reaction where other parts of the bridge become overloaded, leading to a collapse. Buckling can appear in different forms. Torsional buckling makes a component twist along its length, while flexural buckling causes it to bend sideways. Sometimes, only a small part of a member deforms, which is called local buckling. This failure mode is especially dangerous because it can happen suddenly and without much warning. For example, in the Tacoma Narrows Bridge collapse, the bridge twisted and buckled under strong wind forces. The bridge's lightweight design and aerodynamic shape made it prone to torsional buckling, which caused it to sway wildly and eventually break apart. Several factors can cause buckling in bridges. Excessive loads beyond what the structure was designed to handle can push parts into buckling. Corrosion or material deterioration weaken the components, making them more prone to instability. Small imperfections from construction or damage over time can also reduce the stability of slender members. Environmental conditions like high temperatures can change material properties and induce thermal stresses that increase buckling risk. Design flaws are another common cause. If a bridge's components are not stiff enough or have inadequate cross-sectional dimensions, they become more flexible and easier to buckle. Engineers try to prevent buckling by making sure parts are stiff enough, adding braces, choosing stronger materials, and considering environmental effects during design. Regular inspections help spot corrosion or damage early, so maintenance can prevent buckling from leading to failure. Understanding buckling helps explain many bridge failures. It shows that a structure can collapse not just because the material breaks, but because it becomes unstable under load. This knowledge guides engineers to build safer bridges and helps us understand why some structures fail unexpectedly when conditions change or loads increase.